of circuits and networks. In today's class 2 under GATE exam, we'll see some problems and solutions on two-port networks. This will be treating as class 2. In our class 1, we have seen some basic numericals based on impedance parameters. Today we're going to see some admittance parameters and H parameters. So these are the few examples shown in GATE 2018 and GATE 2006. How to solve these kind of problems? Let us go with the session. So in the first problem, you can see a two-port network is shown in the figure is described by the following equation. So clearly, input current, output current in terms of voltage E1, E2 are framed by admittance parameters. It's a general formula which was asked for GATE 2002, and we need to find out admittance parameters. The options are given here. You can see A, B, C, and D. Since these are the admittance parameters, all the units are in mhos. Okay. Then the impedance parameters are given by V1, V2 in terms of impedance parameters, that is I1, I2. When you're going to apply Z parameters to this particular T network, we are going to get the value simply as 4, 2, 2 and 4. How we got this value? You can see when output port is open circuited, 2 and 2 are in series. So naturally Z11 will be 4. In a similar case, when input port is open circuited, you're going to get Z22 value as 2 plus 2, that is 4, and 2 is nothing but the resistance value which is present between port 1 and port 2. So this becomes the transfer impedance value. So whether it is Z21 or Z12, the value will be 2 and 2. Once we get the value of Z parameters, the admittance parameters is obtained as inverse of impedance parameters. So just I have to take help of this matrix and apply inverse to this matrix. So when I'm going to apply inverse to this matrix, this is how the value of the impedance parameters will be obtained in terms of Y parameters. So with this Y parameters, you can easily obtain as 1 by this Z is nothing but the modulus value of 4 into 4, 16 minus 4, and Z22, Z11 replaced by 4 and 4, and minus Z12 and minus Z21 are replaced by minus 2 and minus 2 respectively. With that, we are going to get the admittance parameters as 1 by 3, minus 1 by 6, minus 1 by 6 and 1 by 3. So from the given option, B is the right answer. You can directly apply the admittance parameter solution to this T network and check whether you got the same answer. And please comment in the chat box whether you are able to find out the same value. So this you have to remember as a shortcut value for conversion of admittance parameters from the given impedance parameters. In the next problem, which is shown in this fashion, where you have the input and output conditions shown by this network. This was asked for GATE 2006 for 2 marks, where the parameters of the circuit shown are the input resistance is 1 mega ohm, that is this. The output resistance is 10 ohms, and the gain value of A is given as 10 to the power of 6 volts per meter. And if Vi is equal to 1 microvolts, then the output voltage, input impedance, and output impedance are the options given here as 1 volt, infinity, 10 ohms. Then option B has 1 volt, 0, 10 ohms. C value is 1 volt, 0, infinity, and D value as 10 volts, infinity, and 10 ohms. Okay, in order to solve this kind of problems, once you have to keep in your mind that whether it is V input or Vs, these are nothing but the open parameters over this particular network. Okay, so from the given data and assuming the output voltage as V naught, what I can get the value here as V naught is equal to AVI. How you got AVI? Because it's an open circuit, so naturally the voltage will be measured across AVI. So this is one relation which we can deduce from the given circuit or network. And Vi is already given as 1 microvolt. Then A is nothing but 10 to the power of 6 volts by meter. Now with the help of these three parameters, I can get the value of V naught. V naught will be equivalent to AVI. A is nothing but 10 to the power of 6 volt per meter, and here you have 1 microvolt. So apply these two values over this equation, we are going to get the value of V naught as 1 volt. So this is the first catch. So for the given options, D is not the right answer. Probably A, B, and C are the answers. We need to cross check whether the options are relatively obtained as we further go with the process. Observe the Z infinity, that is Z input value, which is nothing but the measurement of uh, input impedance over this open circuited value. It is infinity. Why it is infinity? Because it's the open circuit and you have source voltage over here, and R1, though it is connected to the source voltage, but since it's open circuit, the value it goes to infinity, so that impedance value will be infinity. So from the given options, you can see the input impedance value is infinity. So option A could be the right answer, because the other two options we don't have Z input impedance as infinity. Those two options are not there, so we need to cross check whether A is the right answer or not. But the final output impedance that we can do by short circuiting the input voltage source. When you short circuit the input voltage source, so naturally Vs will be 0 volts naturally, and Vi, since it's a short circuit value, Vi will also be 0 volts. Once Vi is 0 volts, naturally this voltage controlled voltage source will also be 0 volts. Okay, so you can replace this 0 volts by a short wire like this, where this dependent voltage source will get vanished. So naturally, the output impedance would be equivalent to R naught value, which is nothing but 10 ohms given in the problem, and that is over this particular arrangement. So this is how we obtain the values for the input conditions, output conditions, whether it is input impedance or output impedance. So this is the important problem we need to concentrate. These kind of problems are frequently asked in GATE exams. Option A is the right answer. In the next problem, we need to find out hybrid parameters, that is H11, which is also given by V1 by I1 when V2 is equal to 0 in ohms. This was asked for 1 mark under GATE 2018. What we need to do, so let me solve this problem with two methods. First, we'll follow the method 1, that is the substitution method. What is that? We'll see here. Let us assume two loop currents, I1, which is already here, and I2, and I1 in clockwise and I2 in anti-clockwise. This is how it would be. So this is the assumption what I have taken here. Then I'm going to apply KVL on the loop 1. So you will be having minus V1 plus 1 I1 plus 1 multiplied with I1, multiplied with the sum of currents which is flowing in 1 ohm, that is I1 plus I2 equal to 0. With this I'm going to get the value of V1 in terms of I1 and I2 by this equation 1. Similarly, I'm going to apply KVL in anti-clockwise direction. I'm going to get 3I1 plus 2I2 equal to V2. Now you can see equation 1, equation 2 are in the impedance forms. Okay, so when they are impedance forms, I can directly write the value of impedance matrix as 2, 1, 3, 2. Okay, and since the dependent current source is given over here, that's why here Z12 is not equal to Z21. That is another important point we need to keep in our mind. Whenever the dependent sources are given, Z12 will not be equivalent to Z21. That is, the reciprocity will does not exist, but dependent sources in the given problem. Okay, anyhow, once the Z parameters are obtained, the H parameters are given by 1 by Z22, open bracket, delta Z, Z12 minus Z21 and 1. This is the shortcut formula to directly obtain H parameters when impedance parameters are obtained. You can check our previous classes how to convert these kind of parameters. Otherwise, it's a normal practice. By normal practice, if at all you are able to remember this formula, that is well and good. Otherwise, we'll go with the method 2, that is the conventional approach, and then we'll find out the value of H parameters. Especially, we require H11, that is nothing but V1 by I1 at V2 equal to 0. Anyhow, this H parameters are directly obtained as 1 by 2, 1 by 2, minus 3 by 2, and 1 by 2. And already we have find out the final solution, and the requirement of H11 would be 1 by 2 ohms. So whatever we have done, whether it is right or wrong, let us cross check the result with method 2. What is that? I'm taking the network as it is, which is given in the problem. Then I'm shorting the output voltage, because when you short circuit this voltage V2, you'll be left over with only V1, I1 and I2. So this is how two loops can be framed, and the actual hybrid parameters are given by this particular equation, where you can elaborate V1 in terms of I1 and V2 and I2 in terms of I1 and V2. Okay. Now what we do, we have shorted the output port. With that, I'm going to get V1 and I2 in terms of H11 and H21 in this fashion, where H11 would be V1 by I1 at V2 equal to 0, and H21 will be I2 by I1 at V2 equal to 0. H11, it is nothing but the impedance value, so units will be in ohms. H21 is the ratio of the output current to input current. So this does not contain any kind of unit. Anyhow, what are these two values? Let us find out with the help of equations. So from the first equation, you can see I am applying KVL. So minus V1 plus 1, I1 plus 1, I1 minus I2. This is a convention I have taken of I1 and I2. That's why it is I1 minus I2. Unlike in the previous problem, I have taken the anti-clockwise direction of the current for the substitution method. Okay, that is a different thing. In this approach, we have taken I1 and I2 currents in clockwise direction. That is how this equation is framed. With this, equation 3 is obtained as 2I1 minus I2 equal to V1. Fine. And applying the same logic for loop 2, I'll be getting 1 I2 minus I1 plus 1. Here you can see the loop current is I2, but on the top you have another current which is nothing but 2I1. So it will be I2 minus 2I1, and output voltage is 0. So that is why it is equal to 0. With this, I can frame equation of I2 in terms of I1 as 3 by 2 I1. So equation 4 is also obtained. And with a clear inspection, you can see H21 value can be easily obtained as I2 by I1, which is equal to 3 by 2. Okay. And the direction of the current is opposite to the actual condition of the current what we have assumed. So that's why it would be minus 3 by 2. Anyhow, we'll see it later. First, substitute equation 4 in equation 3, so that I'm going to get the value of H11 as V1 by I1, which is nothing but 1 by 2 ohms. So uh, H1 value is obtained, whose value is 1 by 2 ohms, and H21 is nothing but minus 3 by 2. Since it's a ratio, you have doesn't have any units, and I2 is nothing but the actual current what it is supposed to flow in anti-clockwise direction. That's why it is minus. It is minus over here. Okay. Okay, fine. So we have obtained two parameters of hybrid parameters. Now, when you open circuit the input port, I1 will be 0. I1 is 0, then actually 2I1 will also be 0. In fact, this network will be changed to this network like this. So you have only V2, where you can make the current I2 to flow into the circuit, and voltage V1 can be measured across 1 ohm. Okay, so again taking the actual hybrid parameters equation, and when I1 is 0, V1 in terms of V2 and I2 in terms of V2 is obtained by H12 and H22, whose values can be obtained as V1 by V2 at I1 equal to 0 and I2 by V2 at I1 equal to 0. Anyhow, from this simple loop equation, I can get directly value of V2, which is equal to 2I2. Why this is V2 and this is I1 and 1, this becomes 2. So 2I2 equal to V2, and I2 is flowing in 1 ohm, therefore V1 equal to I2. So equation 5 and 6 are framed. With this, you can easily get the value of H12 and H22. Uh, H12 by dividing equation 6 by 5, you're going to get 1 by 2. And H22 is nothing but I2 by V2, which is again once again equal to 1 by 2 mhos. So it's an admittance parameter. So all these values of H parameters are obtained as 1 by 2, 1 by 2, 3 by 2, and 1 by 2. This conventional is minus 3 by 2. You have to remember that. Anyhow, actually given in the problem, the H11 value is obtained to be 1 by 2 ohms. So this is how we solve the parameters under two-port conditions. I hope you like this class. Please share this channel and subscribe to this channel for future notification. You have to press the bell icon.